We often think that's something that we learn at school we're never going to use again for the rest of our lives. And possibly many of us may have done Pythagoras at school and learned the theorem and think you're never going to see it again. Well, if you do get into the field of electrical engineering, this certainly is something that will pop up from time to time. Pythagoras was a Greek philosopher and mathematician, and he was born in about 570 BC. He lived to the ripe old age of 75 and left us with his theorem. Now, his theorem pretty much evolves around a triangle. And what he says is that if you know two sides of a triangle that has a right angle in it, in other words, an angle of 90 degrees, then you should be able to calculate the third. Let's go and say that that's going to be side A, and that's going to be side B, and that's going to be side C. According to Pythagoras, C squared is going to be the sum of A squared plus B squared. Or you can go calculate it slightly different. You might go and say that B is going to be the square root of C squared minus A squared. Exactly the same thing. We're just going to manipulate it mathematically. Let's go and have a look at an example. In this case, we have been given the lengths of the two shorter sides of a triangle, and we want to get the longer length. We can go and call that A, and that B, and that C. We know that C squared is going to be equal to A squared plus B squared. Or we can go and say that C is going to be the square root of A squared plus B squared. In this case, it's going to be the square root of 5.8 squared plus 4.5 squared. And I like to put that all into brackets just in case you make a mistake with your calculator. And if you do go and calculate that, we should get the following answer. 7.34. And that's going to be in units. Now, I haven't given the units. We could have been working in millimeters. We could have been working in centimeters or in meters. As long as you remember what units you're working with, the calculation is going to be exactly the same. What if we were to have the longer side? And I'm going to go and put in 92 units over there, and maybe one of the short sides I want to put in 75 units. Again, units of your choice. Now let's go mark this as A, B, and C. And in this case, we know that C squared is equal to A squared plus B squared, and therefore we can go and calculate A as being the square root of C squared minus B squared. In our case, that's going to be the square root of 92 squared. Now let's rather put the bracket on the outside of that one. Let's go and do it like that. 92 squared minus the 75 squared. When you're using a calculator, I just like to put the brackets inside so that we don't make any calculation errors at all. And that is going to give me an answer of 53.28 units, whatever the units that you are going to go and work with. Now, you might say to me, why do we need this in real life? Well, imagine if you were standing at this point over there and you wanted to take a cable to that point over there. You could take the long route, which would be the 53.28 meters plus the 75 meters, which would have given you a total length of 128.28 meters. Doesn't it rather make more sense to take the shortest distance? And according to Pythagoras, that's going to be 92 meters. So that's almost 30 meters of cable that you are saving just by knowing what Pythagoras was all about. So, especially in the world of electrical engineering, please pay careful attention to Pythagoras' theorem. It can come in quite useful.